So 10B says the topic is problem solving with geometry. So this first page deals with pitch, grade, and slope. So it says consider the road that rises uniformly 2 feet vertically. So you go up 2 feet for every 20 feet that you go horizontally. We say that the road has a pitch of 2 and 20, or if you reduce it, 2 goes into both the 2 and the 20, so or 1 and 10, meaning you're rising 1 foot for every 10 feet horizontally that you go. It is common to also describe the rise of the road in terms of its slope. In this case, the slope, or rise over run, is 2 over 20, or 1/10. As a percent, then we call it a grade, so then all they took was the 1/10 or 2/20, whichever way you want to look at it, and they times that by 100, and then they get 100%. So pitch, grade, slope, they're pretty much talking about the same stuff, just representing it in a different format. Okay, so Pythagorean theorem, that only applies if you have a right triangle. And with Pythagorean theorem, that's the a squared plus b squared equals c squared, where the a and the b are the two sides that make up the 90-degree angle. So the a and the b are both called legs. And then the c, the side across from the 90-degree angle, is called the hypotenuse. And the hypotenuse is always the longest side of a right triangle. So the legs, whatever those lengths are, they're going to be smaller than whatever the length of C is. And then the A and the B, it doesn't matter which leg you call A and which leg you call B, because either way you're going to square them both and add them together. But the one you have to make sure you always have labeled correctly is the C, the hypotenuse. So this one says, find the area in acres of the mountain lot. So it looks like here we have a triangle. So I would want to do the area formula of a triangle, which is 1/2 base times height. So if I got that, I would do 1/2. My base and my height, the base and the height are the two sides that make up the 90-degree angle. So that 250 is, like say, my base. My height would be this unknown third side right here. So since it's making a right triangle, the side across from the 90 is my hypotenuse, that's my C, and then I could say the 250 is my A, and the side I don't know is my B. So doing Pythagorean theorem to find out that length, I could say 250 squared plus B squared equals the third side squared, which is 1200 squared. And then I'm just going to minus the 250 squared to the other side of the equation. And then just type that into the calculator. So 1200 squared minus 250 squared gives me that number there. And then to get rid of the square that's on the B, I would square root this answer. So I'm just going to go square root of that answer I had there, and it gives me 1173. So now if I want to find the area, I can go 1/2 base times height. So 1/2 250 times my 1173.69. And I get 146,708.68. Now this unit, this was in feet, so since it's area, this would be feet squared. Now this question didn't say to get the answer in feet squared, it wanted to know the area in acres. So I have to know how many feet are in an acre, and I honestly don't have that memorized, so I would either look it up online or look at the reference sheet you guys are given. And on your reference sheet, we have right here that 1 acre is 43,560 square feet. So I'm going to need to use that conversion from the reference sheet to help me figure out how many acres I have. So to convert, I'm going to take this answer in area that I have right now, if I want to get rid of feet squared, I need feet squared down here, and I'm trying to convert to acres. So it said that 1 acre was 43,560 feet squared. So now my feet squared will cancel, and I'll be left with an answer in acres. So I multiply the numbers on the numerator together and then divide by the denominator. So I'll divide by 43,560, and I get 3.367. You'll round however it tells you to round. It'll probably say like round to the nearest tenth or nearest hundredth. So I'm just going to round to the nearest tenth. So I'm just going to go 3.4 acres is the area of that mountain lot. Okay, now we have similar triangles. Two triangles are similar if they're like the same shape but different sizes. So all the corresponding angles of the triangle are going to be the same angle measurement, but the side lengths are going to be longer or shorter. So like angle A is going to be the same angle measurement as A prime, angle B will be the same angle measurement as B prime, and then C will be the same angle measurement as C prime. But these side lengths of C to C prime, you can see that it's shorter. And let's say that this was like C prime was half as long as C. Whatever scale factor C has, then the B and the A have the same scale factor. So like if I times C by a half and B by a half and A by a half, then I would get the lengths here. So whatever the scale factor is, it has to be times each of these sides by that exact same number to get it over here. So it says for two similar triangles, the corresponding pairs of angles in each triangle are equal to each other. And then the ratios or the side lengths of the two triangles are equal. So if I did the side length of A, divided it by A prime, I would get the same answer as if I did B divided by B prime, and I'd get the same answer if I did C divided by C prime. Or I could even flip these around and do A prime over A equals B prime over B equals C prime over C. So it says find the lengths of the sides labeled A and C prime. Now this is assuming we're given that these are similar triangles. So it was missing that piece, but if we're given these are similar triangles. Okay, so when I look at these two triangles, I first want a pair that I know like A and A, B and B, C and C. So when I look here, I know that I can see that I have B prime and I have B. So I'm going to need to use that in one of my ratios. So if I want to solve for A, I can say A over its corresponding A prime, which is 4, should equal B, which was 9, over its corresponding B prime, which was 6. And then that should also equal C, which is 12, over its corresponding C prime. Now, normally I wouldn't set up all three. What I would do is I would just set up 2 of them and then solve for the unknown. So if I wanted to find A, I would do A over 4 equals 9 over 6. And then to solve for A, I can just times both sides of the equation by 4 to get that to cancel. So then I just go 9/6 times 4. And I now know that A is then 6. And then if I wanted to find out what C prime is, I could use this relationship over here. Now, I don't like that my C prime is on the denominator of the fraction. I usually like my unknown to be on the numerator. So what I usually do if that happens is I just flip, I do the reciprocal of each fraction. So instead of doing 9 over 6, I'll just change that to be 6 over 9. And as long as I do the reciprocal on the other side and say C prime over 12, I still have a true statement. So now to solve for C prime, I'm just going to times both sides of the equation by 12. So I'll go 12 times 6/9. And now I know that C prime is 8. Okay, so another problem. You have 32 meters of fence to enclose a corral. What shape should you choose if you want the greatest possible area? A square or a circle? What is the area of this optimized corral? Okay, so since I'm dealing with area, I probably need to know the area formula of a square. And A square has all the sides the same length. So whatever this side length is, this side is also the same length. So area is length times width, or side times side, or S times S, which would be S squared. So there's my formula for my area of a square. And then area of a circle is pi r squared, where r is the radius, which is the distance from the center over on the circle. Now where it said I had 132 meters of fencing to enclose the corral and I want to get the greatest area, that means if I made a square, I have 132 feet to go all the way around. If I made a circle, I have 132 feet to go all the way around. So with the square, they're talking about perimeter. And since all of these sides on the square are the same length, I have 4 sides of the same length. My formula for perimeter would be 4s, or s plus s plus s plus s. On a circle, the distance around a circle, instead of calling that a perimeter, with a circle, we usually call that circumference. So the formula for circumference is 2 pi r, or 2 times the radius is the same as the diameter, so I could also say the diameter times pi. So basically, I'm going to need to find the perimeter of the area of the square and the circumference of the circle and find out which one of those gives me the larger answer. So I know I have 132 meters available. So here I'd replace the perimeter with 132. On this one, I would replace the circumference with 132. So for the square, I'm going to go 132 equals 4s. Solving for s, I'll divide by 4. So 132 divided by 4 is going to give me 33. Now if I want then the area of that square, since each side length is 33, the formula said side squared, so I'm just going to go 33 and square it. So that's going to have 1,089. And then this was in meters, so meters squared. Okay, now dealing with the circle, I'll have the circumference of 132 equals, I'm just going to do it in terms of the 2 pi r instead of diameter times pi. So I'll go 2 pi r. So then to solve for r, I divide by my 2 pi. So 132 divided by 2 pi, and I make sure I put my 2 pi in parentheses so I don't end up with a dividing issue. So I get 21.008. If I didn't use parentheses, I would get the wrong answer if I just typed in 2 pi like this without the parentheses, because what the calculator is going to do is it'll divide the 132 by 2, get that answer, and then times it by pi. So I get a completely different answer. So when you're using your calculator, just be careful when you're doing division to make sure you're dividing the entire thing by whatever the denominator is, or type it in your calculator as a fraction to begin with, and then you don't have to worry about the parentheses. Okay, so now that I know my radius, if I want the area of the circle, I'm going to go area equals pi, and then my r squared. And I get 1386.557, and then that would be meters squared. So the one that's going to be bigger is the circle. So the circle is the one that will optimize or make it so you have the largest corral available with the 132 meters of fencing available. And then if your question says how much larger, you could just subtract these two areas and find out how much larger it is. Okay, so last example. Telephone cable must be laid from a terminal box on the shore of a large lake to an island. The cable costs $700 per mile to lay underground and $1,100 per mile to lay underwater. The location of the terminal box the island and the shore are shown to the right. As the engineer on the project, you decide to lay 6 miles along the shore underground, and then lay the remainder of the cable along the straight line water to the island. So it looks like, so straight that way and then straight up to the island. That's going to be your path. Your boss examines your proposal and asks whether laying 7 miles of cable underground before starting under the underwater cable would be more economical. How much would your boss's proposal cost? Well, you still have a job, so were you better than your boss, basically? It looks like my picture doesn't match the words up here, so I'm going to change the picture because it says you're going to do 7 miles for the boss. Okay, so here's the bosses. You go 7 miles this way, and then after you go 7 miles that way, then you go straight up 1 mile underwater. Okay, so I'm going to figure out your cost first. So we first need to know how much right here you're going to do underwater. So since it's from here to here is 7 miles, and you go 6 miles this direction, that means you're going to go 1 mile. There's 1 mile right here to give us the total 7 miles. So basically, if I want to find this length, I have a right triangle. So I'm going to be doing Pythagorean theorem. A squared plus b squared equals c squared. So my a and b are both going to be 1. So I go 1 squared plus 1 squared equals c squared. 1 squared is 1, so I get 1 plus 1, which is 2. So I have 2 equals c squared. So c, I square root that, and c is going to be root 2. So you're going to have root 2 miles that you're going to do underwater. Okay, so it says it's going to cost you $700 per mile underground and $1,100 per mile to lay underwater. So you're going to do 6 miles, that's just underground. So it's going to be 6 times that 700 per mile, plus you're going to do root 2 miles underwater times by the 1,100. Okay, so yours is going to cost $5,755 approximately. Now for your boss's proposal, he's going 7 miles out underground. So 7 miles times the $700 per mile plus, and then he's going 1 mile underwater. So 1 times the 1,100. And his is going to cost $6,000. Okay, so based on that, I would say, yes, you'll still have a job. Your proposal saved almost $300. Your bosses would cost an extra almost $300, $250-ish.